So when evaluating logarithms, you want to remember the fundamental question, which is the base to what power equals this number. That's the question you have to answer. So here I say 5 to what power equals 125. Well, it's 5 to the third power that equals 125. So that's why it is equal to 3. The output should be the exponent. So if we remember that, we can look at some examples. 2 to what power equals 64? Well, it would be 2 to the 6th power. So this is equal to 6. Here, we want to remember, oh, that's base 10. So 10 to what power would equal 0.01? Scientific notation might help you with that because the decimal has moved over. And so another way to think about it is also that 0.01 is 1 over 100. And so if you've got 1 over 100, that's 1 over 10 squared. And then that would be 10 to the negative 2. So 10 to the negative 2 power would be equal to 0.01. And here, 16 to what power would be equal to 2? Well, 16 is 2 to the 4th power. So 2 to the 4th power, 4 wouldn't work because it's not 16 to the 4th power that equals 2, but the 4th root of 16 would be equal to 2. And we know that roots are the same thing as fraction exponents. So that's what fractions mean when you get them from an exponent. So let's talk about your calculators. Here are a couple of calculators. Always kind of depends on the type of calculator you're using. These are a couple of examples of phone calculators. Phone calculators do usually have logs on them. You'll see LOG and LN, LOG and LN. Do be aware that if you see these two buttons on a calculator, they are specifically log base 10 and log base E. You can't just type on your calculator, log of 8 if what you're looking for is log base 2 of 8. Okay, so you want to make sure that you understand that these buttons, as they are programmed into calculators, are just log base 10 and the natural log base E. So you have to make sure that you know how to do these other bases if that's not, if the problem is log base 2 of 8, how do you type that in your calculator? So you can still do it on a phone calculator. If you're using one of the graphing calculators, they do usually have an option to put a base in there. And so again, it just depends on the version of the calculator that you're looking at. But if you're using a calculator that just has log base 10 or just has log base E, you can still do those other log bases, but you have to use the change of base formula. So everybody should have their calculator. I want you guys to try this. The change of base formula allows you to use your phone calculator or any calculator that just has the log base 10 button or the natural log button. You can use either one of them. But if I have a log base B of A, to find that log, all I have to do is take the common log of A divided by the common log of B, or the natural log of A divided by the natural log of B. Both of those will work. And we call this the change of base formula because we're changing it from being the base of B to being either base 10 or base E, because those are the buttons we actually have on our calculator. So on your calculator, I want you to find log base 2 of 64 so we can check our answer that we put on the slide before. So if we're going to do that in our calculator, what I'm going to type into my calculator is going to be log of 64 divided by log of 2. And what do you get? 6. Look at that. So you can. Now, I do know the graphing calculators. If you go to math there's an option that says log base. And it will give you a log that it lets you type a little base down in there on. But it's not exactly convenient to get to because you do have to go through the math menu. I don't always have one of the graphing calculators with me, but I usually have my phone with me. So a lot of times I'm using my phone. So I do find that the change of base formula is critical to know, just so that you can do any log no matter where you are. Any calculator is going to have log base 10 and natural log on it. So I can still do all those other logs even if my calculator just has those two logs on it. All right. So here are some logs for you to evaluate. Everybody go ahead with your calculator and evaluate these logs. All right, so what did you guys get for logs base 2 of 75, Kayla? 6.2, blah, blah, blah. How about that natural log, Harris, for number 4? What did you get? 2.662. Alex, how about number 2? 1.6. What? Did you not get 1.6? Oh, let's look at that one then. So log of 37. Who else did log of 37? Danny, what did you get? It is 1.6. Okay, we had a dissenting voice. I just wanted to make sure before we moved on. Danny, what did you get for 5?
For 5, I received negative 5.21.
Negative 5.21. You can have negative outcomes. And then log base 16 of that big long decimal. Soledad, what'd you get? 0.2. All right. So it is very important that you do know how to use the calculator correctly to evaluate logs, because if we are going to solve exponential equations, it's going to require logs. And if we are going to solve logarithmic equations, it is going to involve exponentials. And it is often going to involve decimals. So calculators are your best friend when it comes to exponentials and logs. We do have some basic identities of logs, just like we have laws of exponents. Anything to the 0 power equals what? Anything to the 0 power equals 1. So that means that if I have a log of 1, it doesn't really matter what that base is, because anything to the 0 power is equal to 1. So just like anything to the 0 power is equal to 1, any log of 1 is equal to 0. So those two laws go together, that property of exponents and that basic identity, those go hand in hand. Another one is anything to the first power is equal to what? Itself. Anything to the first power is just equal to itself. So that means anytime you take a log base of itself, then it's just going to be equal to 1. Yeah, so if the base and the number that you're evaluating are the same, the only exponent that gives you the same thing is 1. And anytime that you have the bases match, this is a logarithm and this is an exponential. And what did we say logarithms and exponentials are to each other? They are inverses of each other. And what do inverses do to each other? They cancel each other out. Think about taking the square root of a square. The square root and the square cancel out. The cube root and a cube, they are inverses. They just cancel each other out. So if I have a logarithm of an exponential, and they are the same base, just like up here, a cube root doesn't cancel out a square. Like those are not inverses of each other. They did have to be the same number, right? Those would not cancel each other out. So if the base of the log and the base of the exponential are the same, they just cancel each other out, and you're just left with the exponent. And then you can actually do that backwards as well. if you have an exponential of the log, it's the same thing. They're still going to cancel, and it's just going to be equal to x. Just like if I had a square root and then I squared it, they just canceled out. So it just looks weird when you have that logarithm actually up in the exponent. It's weird looking. But they are inverses of each other. That's what inverses do. They undo each other. They cancel each other out. That's their point. That's why we have them. So make sure you know those. So we can look at some examples of that. This is log base 10 of an exponential base 10. So what are they going to do to each other? Cancel. And it's just 4. This is a natural log, base e, and an exponential, base e. What are they going to do? Cancel each other out. And then I'm just left with 4x minus 3. Natural log of e cancels. Natural log of 10 cancels. Negative 3x plus 1, right? Yeah. And then this one, oh, that's just the same number. Yeah. Anything to the first power is equal to itself. So those are ones that you always want to watch for because you can very easily cancel them out and move on in the equation. And usually it's gotten a lot easier because you've canceled out all the hard stuff. That's something that you will definitely want to watch for.